Guarantee that you will never fear trigonometry ever again. I will make trigonometry so simple that you will understand it once and for all. We will start with the very basics. I will try my best so that there will be no jargon, no confusion, and just crystal clear explanations that might stick with you forever. So, what is trigonometry? At its core, trigonometry is just a branch of mathematics that deals with the relationships between the angles and sides of triangles. Think of it as the math of triangles. Before we dive into the details, let's focus on a special kind of triangle from where this trigonometry started: the right-angled triangle. As you might probably know, a right-angled triangle is a triangle where one of the angles is exactly 90 degrees. Now, every right-angled triangle has three sides. The hypotenuse. This is the longest side of the triangle, and it is always opposite to the right angle, or this 90 degrees. Also, we label it as H in short. Then comes the opposite side. This is the side opposite to the angle you're focusing on. We like to label it as O for the opposite. Then we have the adjacent side. This is the side next to the angle you're focusing on, but not the hypotenuse, and we like to label it as A for the adjacent. So, if you are looking at this angle, then this will be your opposite side, and this will be your adjacent side. And for this angle, this will be your opposite side, and this will be your adjacent side. But the hypotenuse will always remain the same, no matter which angle we are focusing on. Always opposite to the right angle. So far, so good. But before we go further, let me tell you, why is trigonometry important? It's not just about solving math problems in school. Architects use it to design buildings, engineers use it to build bridges, pilots use it to navigate airplanes, and even game developers use it to create realistic 3D graphics. Okay, so back to our right-angled triangle. The heart of trigonometry lies in three magical ratios: sine, cosine, or cos in short, and tangent, or tan in short. These three ratios are the key to unlocking the relationships between the angles and sides of a triangle. Let me break them down for you. Let us call this angle as theta. So now we take the length of this opposite side, or O, and then just divide it with the length of this hypotenuse, or H. And we simply call this fraction as sine of theta. And that's it. Nothing fancy here. Similarly, we take the length of this adjacent side, or A, and then just divide it with the length of this hypotenuse, or H, and we simply call this fraction as the cos of theta. Then finally, we take the length of this opposite side, or O, and then just divide it with the length of this adjacent side, or A, and we simply call this fraction as the tan of theta. That's really it. Believe me, trigonometry is nothing more than this. Here's a super simple way to remember these. I know it may sound funny or weird, but this phrase is a nice shortcut to remember these ratios. So, ka, to, ah. Here so stands for the sine of theta, which is equal to the opposite side, or O, over the hypotenuse, or H. Similarly, ka stands for the cos of theta, which is equal to the adjacent side, or A, over the hypotenuse, or H. And yes, you guessed it right. To, ah stands for the tan of theta, which is equal to the opposite side, or O over the adjacent side, or A. Say it out loud a few times, and it'll stick in your head forever. Now, suppose the ladder is 5 units long and this point is 3 units away from the wall. Then, what will be the values of these three ratios? Assume this is the angle theta we are focusing on. It's simple, right? First, we can use Pythagoras' theorem to find the value of the length of this wall. Let us label it as O. We get 5 square equals 3 square plus O square. So, we get O square equals 25 minus 9, or 16, and thus O equals 4. Now we have the hypotenuse, or h, equals 5, and the adjacent side, or a, equals 3. So, using this, we get sine of theta equals O over h, or 4 over 5, cos theta equals A over h, or 3 over 5, and tan of theta equals O over A, or 4 over 3. That was simply amazing! Now here's one more interesting fact. Let us divide the sine of theta over cos of theta. Substitute this sine and cos here. We get it as O over h divided by A over h, which gives us O over A. Oh, look! This is equal to tangent of theta. So we have sine theta over cos theta equals tan of theta. Amazing! Now let's talk about some standard angles and their values for sine, cos, and tan. These angles are like the favorite numbers of trigonometry because they come up so often in problems and applications. The most common standard angles are 0, 30, 45, 60, and 90 degrees. To make it super simple, here is a little table that gives you the values. Many of you would have just memorized it but have no idea how we have got these values. Let's break it down further. The sign of 0 is 0. As you can see for the ladder example, it means that the ladder is resting on the ground. So the wall height is 0, and therefore this ratio is also 0. While the cos of 0 is 1, because the hypotenuse, or this ladder, is fully along the adjacent side, or the ground. Thus this ratio is 1, and tan of 0 is sine over cos, or 0. Getting the values for 90 degrees is also super easy. Keep the ladder like this. So, this angle, theta, will be 90 degrees, right? Therefore, the opposite side will be the same as hypotenuse, or the length of this ladder, and the adjacent side will be 0. So, sine theta equals 1, and cos theta equals 0. And tan of theta, it is undefined because we cannot divide by 0. But why is that? To understand it better, I have made a video on the same. Link is in the description. Go check it out.